Welcome to Dr. Tarazi's Math Site. This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Functions make up almost 1/4 of the test questions. Standard 8.F.2. Define, evaluate, and compare functions. Compare properties of two functions each represented in a different way. This standard is very important. 2 to 4 questions are on the test every year.
Hello and welcome. Here is what you need to know before we get to the examples.
Rate of change and slope.
Given any 2 points, x1, y1 and x2, y2 on a straight line or in a table representing straight line, then the rate of change is the slope is equal to y2 minus y1 over x2 minus x1, rise over run.
Y equals mx plus b.
This is the equation of a straight line where m is the slope, rate of change, b is the y-intercept where the line crosses the y-axis. Is when x is 0, you get y is equal to b, that is the y-intercept. Rate of change and slope will be studied in the following examples. Example number 1. This was in the year 2023, question number 36. It says here a scientific recorded the temperatures of 2 different liquids as they were heated. The results are shown in the table and graph. So this is one kind of questions they ask you, a table and a graph. I just want to remind you once, every time you see this picture here, you may pause the video and solve the problem and come back and check your answer. So what does this table here tells us? It tells us at the beginning when we started heating the liquid, the temperature was 18. And then after 5 minutes, it went up to 35.5, 10 minutes, 53, and so on. This one here, it gives you also the temperature started at 20 and kept on increasing. So if you look at 6 here, 6 minutes, it was 40. You go here like 18 minutes, it was 80 degrees. So you're talking about which one is a slower rate, which one starts with higher or lower temperature. That's what those questions are. So in order to answer these questions, we need to find the rates for this function and for this function as well. So here we are going by 5, increasing by 5, and here we are increasing by 17.5. So you divide 17.5, divide by 5, you get 35. You get 3.5. Yeah, and that shows you like y2 minus y1 over x2 minus x1. Okay, so now we go to the second one. They were nice enough to give you 2 points, these 2 points. Always you have to use 2 points on the grid points, like this one. You can use this one. You can use this one. So they already gave you these 2 points, so you have 60 and 18. 60 is 80 minus 20. That's the rise, and that's the run. So you divide these, you get 3.3 repeated. Now, now we have all the information to be able to answer this question, this question here. What statement is true? So here the rate is higher, see? And here the starting point temperature 18 is lower. So let's see what the options they're giving us. Liquid 1 heated at a slower rate than liquid 2. Is that slower? That's not slower. So that you just cancel that. You don't have to look at the second part of the sentence. Here, liquid 1 heated at a slower rate. Again, the same problem. It's not a slower rate. It's not slower than this. Liquid 1 heated at a faster rate than liquid 2. That's true. Now let's look at the rest of the sentence here. And had a higher starting temperature 18 is not higher than 20, so you cancel that one too. And now liquid 1 heated at a faster rate, yes. And lower starting temperature, 18, 20, yes. And that is your answer here. Question number 2. Two linear functions are given. Function 1 is given by a table. Function 2 is given by an equation or formula. Select a phrase for each blank box to complete the statement that correctly compare the two functions. We are comparing now functions. Remember, the whole title of this standard is comparing functions. So she is talking about slope, comparing the slopes and comparing the y-intercept. So that's important. We are comparing the slopes and the y-intercept. So we need to calculate those quantities first. So slope for function 1, we need the slope. So we need we can take any 2 points here and do y2 minus y1 divided by x2 minus x1. Here I did all these differences here. There's 13 here, 30, the same 13, and that's 1 here. So 13 divided by 1 is the slope. That's 13. Now the y-intercept is when x is 0. When x is 0 is 351. That's good. The second one, function 2, slope of function 2 is 9, and the y-intercept is when x is 0. When you cancel this, y is 396. So now I have all the information I needed. So I start reading here. The slope of function 1 is what? Is higher, is greater than the slope of function 2. The y-intercept of function 1, y-intercept of function 1 is 351, is less than the slope of the y-intercept of function 2. And that's it. You get a full mark for that. It's good. Question number 3, that was in 2021. Steve and Mark are each filling their own bucket with water. Stephen begins with 8 cups of water in his bucket and fills the bucket at a rate of 2 cups per second. The number of cups of water W in Mark's bucket after t seconds is represented by the equation. So here you are comparing some kind of language is giving you here. It's not a table. And then you have a formula, you have an equation here. So another comparisons. Again here, when you read the statements, Mark begins with more cups of water, begins with the same amount, and then Mark fills his bucket at a faster rate. So we need to find the rate. So let's see. The Mark is given is 8t plus 1. Stephen, we have to find that for Stephen. Stephen started with 8, so that's your at the beginning, and then at a rate of 2, that's the rate of 2. Now I have all what I need here. So green are the rates, blue are the starting points. Now I can go here and look at every statement here. Mark begins with more cups of water. Mark begins with more cups of water? No. Option 1, is 1 greater than 8? No. Mark begins with the same amount of water. Is 1 is equal to 8? No. Mark fills his bucket at a faster rate than Stephen. Mark at a faster rate than Stephen? Yeah, 8 greater than 2. So that's good. Mark fills his bucket at the same rate? No. And that's it. Question number 4. 2 plumbers charge an initial fee at an hourly rate. The equation y is equal to 100 plus 30x models plumber A's fees, which means 100 initial fee plus $30 an hour. Okay. Now plumber B is giving the information is giving in a table. So we're comparing again now a equation was a table here. Again, they're asking about the rates and the initial fees and so on and so forth. So let's work on put down the information. Now, plumber A is given 100 plus 30x. Now, for plumber B, we need to find the rate of change. So we make here the differences here. So we are going by 50 by 55, here by 1. So it's obviously it's $55 an hour. Now, this is $105 here. That represents the initial fee plus 1 hour. So if the hourly rate is 55, obviously the initial rate is 50. So now I have all the information I need. This is the initial fee, and this is the hourly rate. And now let's read here and see what happened. The two plumbers have equal hourly rate? No. Plumber A has a greater initial fee? Yeah. Plumber A has a greater hourly rate? No. The two plumbers have equal initial fees? Are these equal? No. And that's it. Example number 5. Pumps are used to empty water from two tanks. Tank P and tank Q. Tank P begins with 65 and empties at a rate of 6.5 gallons per minute. The amount of water in tank Q is represented by the equation. Again, the same similar question, and they're going to ask you about the initial starting amount and the rate and so on and so forth. So let's see what happens here. First of all, tank P, it's 65 gallons. We're starting with 65. And we are emptying it at a rate of 6.5 gallons per minute. Remember, this is minus because we are reducing the amount of water, so we're going down. The tank Q is given. Now you have all the information you need. This is the starting point here, right here, and this is the rate. That's the rate. So now you go and read each one of these statements. Tank P empties at a faster rate. That's faster. Yeah, this one is bigger than this, and had a lesser starting point. Is this less than this? No. So you have to read the whole thing. Tank P empties at a faster rate than tank Q. Faster rate, yes. And a greater amount than tank Q. This is greater than this, yes. Tank P empties at a slower rate. No. Tank P empties at slower rate. No, we're done. Question number 6. Layla and Doane each sell tickets at a concert. They start selling the tickets at the same time. Layla starts with 500 tickets and sells them at an average rate of 5 tickets per minute. The number of tickets T. Duane has left after M minutes is represented in the table below. Again, the same thing. They're going to ask you the average rate, comparing the average rate and comparing the amount they started with. So let's see. Let's put the information here. Layla, it started with 500, okay, and she's selling 5 tickets per minute. Minus 5. Minus because we are reducing the amount of tickets she has. She's selling them. For Duane, okay, so the starting when M is 0, he started with 600, and let's look the average the rate here. The average rate, this is going down by 20, so that's 20 divided by 4, which is 5. So now you are comparing this equation with this equation, okay? So let's read now what options we have. Duane's average rate of tickets sold per minute is higher. Is this higher than this? No. Layla's average rate of tickets sold per minute is higher than Duane. Layla is higher. Average rate, no. Dwayne begins with more tickets than Layla. Yep, see? Yep. Layla begins with more tickets than Dwayne. It's obviously it's no, because that's the opposite of this. Okay, that's it. Question number 7. Charlie and Susan are planning a party for 10 people. Charlie finds a location that charges an initial fee of $20 plus a $25 per person. Susan finds a location whose rental fee is represented by the equation. So another equation here is given to us, where X is the number of people in attendance and Y is the total cost. Select all the statements that are true. Now, when they say select all, it means normally it means more than one good answer. So again, they're talking about which location is cheaper, and so on and so forth. So let's see, put the information first. Charlie's, it's what, $20 initial fee plus $25 per person. $25 per person plus $20 initial fee. Susan is given. Now, green here is the rate. This is the initial fee, okay? And now let's see for 10 people. For 10 people, you replace X by 10 here. That's 250 plus 20 is 270. By times 10, 150 and 100 is 250. So Charlie's location is cheaper location. I mean, obviously for 10 is not cheaper, see, so it's not true. I don't like the way this is worded. I would say I would put here Charlie's location is always, and then see if it's true or not. So Charlie's, in this situation, since you have it for 10, 270, no, that obviously no, for 10 is not. Charlie's location is 270. Okay, let's see. Charlie's location is cheaper location. No, it's not cheaper. See, 217. Now, obviously, if you take X, for instance, if you take X 2, you get here 50, you get 70. Here you get more than that, so it becomes cheaper. So it's cheaper for some values, but it's not cheaper for all values of X. So the answer to this question is no. Susan's location is cheaper for 10 people? Yes. See? The charge for each additional person is greater for Susan's location. Is this greater than this? No. The charge for each additional person is greater for Charlie's location? Yeah. If the number of people at the party changes to 12, the total cost at each location is the same. You can't answer this before finding the values, the cost for 10 people. So when X is for 12 people, when X is 12, we put 12 here. You get 320, you put 12 here, 280. And they're asking you, are they the same? They are not the same. That's it. Example number 8, it's a very similar example, so let's go through it fast. Jaden and Brock are planning a dance for 25 people. Jaden finds a location that charges an initial rental fee of $30 plus 15 per person. Brock finds a location whose rental fee is represented by the equation. Again, they're asking you about which one is cheaper, which one charges more per person. So let's put the information here. Jaden's is 15x plus 30. Where did I get this from? It's $30 is the initial rental fee and 15 per hour. 15 per hour. The other one is given 20. Now, when it happens like this is really easy because 15 is less than 20 and 30 is less than 45. For sure, Jaden's is cheaper. Okay, Jaden location is cheaper. And let's see for 25 what happened, because we have 25 people. You put 25 here, and you put 25 here. And it's not surprising that this is cheaper than this, because 15 is less than 20 and 30 is less than 45. So the first question is yes. Second question is Brock's location is cheaper. Is this cheaper than this? No. The charge for each additional person is greater for Brock's location. Greater, yeah. The charge of each additional person is greater for Jaden's. That's the opposite of this, so that obviously is no. If the number of people at the party changes to 7, the total cost at each location is the same. So let's see how much it costs for 7 people. And are they the same? No. Okay, that's it. Okay, this one is very similar. Brendan and Riley are planning a party for 15 people. Brendan finds a location that charges an initial rental fee. Okay, so the same thing. So if I put the information here, I get this. Now from here, you can't really tell because this is less than this and this one is greater than this. So is Riley's location is cheaper location? Is this is cheaper all the time? So if you put x1, one here you get 20, 20. You do the same. If you put x2, for instance, here you will have 30, here you will have 25. This will be cheaper. So it's not always cheaper. So Riley's location, is it always cheaper location? The answer is no. But let's see for 15 people what happened. 15 here, 90. 15 here, 160. So now the question, Riley's location is cheaper location? No. See? No. Brendan's location is cheaper for 15 people? Yeah. They told you 15 people because for less than people, like for if you take 2 people here, that you will get 10, 25. Here you will get 20. So Brendan will not be cheaper, okay? Yeah, if you get 25 and get here. Put 2 here. If you put 2 here, you get 25. You put 2 here, you get 30, okay? So that 30 is not cheaper than 25. Okay, so now the charge for each additional person is greater for Larry's. Yeah. The charge for each additional person is greater for Brendan's. That's opposite of that, so it can't be true. If the number of people at the party changes to 1, the total cost at each location is the same. So let's find out. Yeah. Okay, this one I'm going to go through it quickly. So it's just similar to the other one. So I will just give you the information here. Very similar to the previous one. This is an interesting question. That's a practice test number 14. Brian and Tim both ride their bikes at a constant speed and leave from the same location. Brian's ride times are shown in the table. Here we go. So 8 minutes he did 1 mile, 16 minutes he did 2 miles. So he's doing 1 mile every 8 minutes. Tim rides faster than Brian. What graph could represent Tim's bike ride? What graph? It should be faster. So we're comparing the slope of these functions here with the slope of this, or the rate of change of this function here. So here the slope is 1 over 8. 2 minus 1 is 1, divided by 8 is 1 over 8. The slope here, you need to find point on the grid. So if I took this point here, I get 1, see, 1 over 8. If I take this point here on the grid, that gives me 9, 1 over 9, 1 over 6, 1 over 10. And obviously we need something bigger than 1 over 8, which is 1 over 6. So 1 over 6 is bigger than any of the other functions. What you can do with this question also, look, after 8 minutes, this guy, Brian, did 1 mile. Here is the same. Here, after 8 minutes, look at the 8 minutes here, he did more than 1. See, that's the one right here. So immediately you have the answer. If you look here at 8, he did less. See, this point here is less than 1. Here, 8, this point here is less than this. A table of values of function A and the graph of function B are shown. They give you questions like that, comparing a table and a graph. Create an equation of a third linear function with a rate of change that is between the rates of change for function A and function B, between them. So we need to find the rate of change, basically. So for this one here, you need to pick up 2 points. So I picked up these 2 points. See, the rise here is 2, run here is 5. Rate is 2 over 5, which is 0.4. Here you take 4 minus 2.5 is 1.5 divided by 2 is 0.75. Rate of change is between. We need between these two. So which means you have an infinite number of solutions. Here's one simple one, 0.5. Now, if you want, you can have here plus 2. You can have y equals 0.6 minus 4 plus 4. Okay, so you have an infinite number of solutions where the rate of change will be between 0.4 and 0.75. Okay?
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.
Thank you, and see you soon.
Thank you for watching. More videos to come. Please subscribe.